All right, so let's do another graph of a log function. This one's a little more difficult. Again, we need to find the domain of the function. This value here, tell me about it. Think about it. Are there any limits on it? Yeah, it has to be greater than 0. Can't be 0. So you have to do some figuring. X plus 2 is greater than 0. So x is greater than negative 2. Right? Negative 2 gives you 0 in there. Are you cool with that? But how am I going to write this so that you get credit on it? Use that notation again. Negative 2 here, infinity here. Can x be negative 2? No. If x was able to be negative 2, remember I would use this square bracket? But we're not using that because x cannot be 2. Just to remember. That notation is very important. So, let's get rid of this other stuff. We don't need it now. That's the notation for the answer. Okay, next thing I need is the X-Intercept. Is there an X-Intercept? How do you find it? Set the equation equal to 0. All right, so let's do some work here. 0 equals minus log base 6 of x plus 2. Now that I set it equal to 0, do you know how to solve that? Base to the exponent. So 6 to the 0 equals what? X plus 2. You know, I forgot to do a step. That negative. Let's multiply both sides of the equation by -1 first to make it all positive. Doesn't really change anything. Now, this step looks a little bit better. So be careful if you have a negative there. All right, so 6 to the 0 equals x plus 2. What's 6 to the 0? 1 equals x plus 2. So what does x equal? Subtract 2 from both sides. Did you get -1? So what is that? That's an intercept. What is the intercept? X is -1. Y is 0. Or f of x is 0. So we have the intercept. We have the domain. We have the x-intercept. Are there any vertical asymptotes? Well, take this part here, solve it for x. X plus 2 equals 0. X equals -2. So we have a vertical asymptote at x equals -2. Now, what else can we do? All right, so we have just about everything we need to graph except for the y-intercept. So let's take this equation again and go y equals minus log base 6 of x plus 2. And let's write that as an exponent equation. You know how to do that? 6 to the y. Uh-oh, that negative's giving me a problem again. What should I do with it? Let's make -y equals log base 6 x plus 2. Be careful of those negatives. All right, so at this point, I'm going to do 6 base to the exponent. So 6 to the -y equals x plus 2. So 6 to the -y minus 2 equals x. And this is how I can find out where we cross the y-axis. So again, let's get our little graph paper up here. Lots some points that we have. We have the X-intercept. All right, here's Y, here's X. So, where is the X-intercept? Negative 1, 0. Negative 1, 0. What's our domain? Any values greater than or equal to negative 2. So I can't have negative 2 here. Vertical asymptote, x equals negative 2. We found that earlier, so let's put that in here. That's this line here. So we can't hit that value, right? What else should we do? All right. We have a vertical asymptote. We have our x-intercept, negative 1, 0. And we know we cross the y-axis at that value there. And if you figure that out, where is that exactly? It's really right very close to here. So we're down in there somewhere. And up here. So there is our graph. Hope that helps. Okay, so remember in the last graph we did make a chart for some points. I don't know about you, but that really wasn't enough points for me to be happy that I have the right curve. So let's put some points in that we know we can figure out in this log formula. And remember, if that value was a 6, log base 6 of 6, I know that I would have this whole value be 1. What number could I put there for an x? Oh, I hope you thought 4, right? 4 plus 2 is 6. So, when x is 4, this value, the f of x value, becomes log base 6, which is 1. There's a minus in front of it, so it's minus 1. Everybody cool with how I got that? All right. What are some other nice values that I might want? Remember I said if that's a 1, what's the log base 6 of 1? It's 0, right? So how do I get that to be a 1? What value of x should I use? Negative 1. And I can get that to be a 0. You know, some other nice values. You notice I was trying to think of what I could get for values here. Some other nice values. So now here on the graph at negative 1, I'm at 0. We had that one before. But at 4, 1, 2, 3, 4, I'm down to negative 1. So I guess my curve was good, but now I have a point, and now I know I'm good. It would be nice if I had some other values down here, like 1 and 2. So I wonder what happens there. So that means my f of x is 1. So how do I figure what the x would be? 1 equals minus log base 6 x plus 2. How can I solve that for x? Exponent form. 6 to the 1. 6 to the 1 equals, oh dear, we've got that negative again. Let's backtrack a minute. Let's make this negative 1 equals log base 6 x plus 2. Now we're going somewhere. 6 to the negative 1 equals x plus 2. Well, 6 to the negative 1 is 1/6 equals x plus 2. So x equals 1/6 take away 2. Graphing calculator can figure that out for us. What do you get? Negative 11/6. That's negative 1 5/6. So negative 1 5/6 goes here. So when I'm over here almost to 2, 1 5/6, I'm up to 1. Okay, that fits. Let's try solving for the 2. All right. we can do that. So that means 2 equals minus log base 6 x plus 2. So minus 2 equals log base 6 x plus 2. Exponent form again, 6 to the negative 2 equals x plus 2. That's 1 over 6 squared, 36, equals x plus 2. Calculator to figure that out, and you get negative 1 and 35 over 36. So at 2, I'm even closer to that line, right? So at negative 1 and 35, 36, I'm up to 2. So, I guess my graph is right. What's weird about this is we kind of did the chart different than normal. Normally you pick numbers up here and you find the f of x values or the y values. But in log equations, sometimes it's better to figure out what you want here and work backwards. So try that when you